So this is a picture of our headquarters in Holland. And just a few facts about the company. We started in 1967. It was actually a cucumber grower who started the business. He got an allergic reaction to chemical sprays for spider mite control and had to find an alternative. And found that he could make more money selling little predators to neighboring cucumber growers than he could growing cucumbers. So this is how the business started. And now we have almost 2,000 employees and 27 daughter companies around the world. But it's still a family-run company. That's the way it works. It's run by the Koppert family, and there's maybe 15, 20 Koppert family members in the company and board of directors and right throughout the company. What just said, the last little bit there on that slide talks about the fact that we're not just biocontrol. We look at the whole plant. So we're looking at plant management in terms of biostimulants as well as pollination and biocontrol. So it's a whole holistic view we're looking at now within the company. Next slide. So there are really three branches to our company. We're heavily into research and development all the time. Then we're into the actual sales and advice of our products throughout the world. And we like to share our knowledge. We're a knowledge sharing company. There's actually a book you can avail of. We produced it 2 years ago with a lot of our knowledge in the book called Knowing and Recognizing. For instance, that's one way. We work through universities as well, like the University of Wageningen and so on, to share our knowledge. Slide, please. So, black vine weevil control, we're going to look at, first of all, the biology of the black vine weevil, a little bit about it. So, slide. This first slide is really talking about how you recognize it and what it does. So, this is the black vine weevil. You can see that we all probably know that we've got the adult and the larval stage here, the first two pictures, and then below that you can see the adult on a leaf and the feeding marks, C-shaped notches on the fourth picture there on the bottom corner of the four photographs. So the vine weevil, we know they feed on the roots of many plant species. We're going to look at some of those a whole list of species further in the presentation. And we all know that they can destroy plants by feeding on the roots, and they even get into the actual core of the plants. Especially severe in young plants, the young plug plants, if they don't get established before they get going on them. So hence the reason why we're all concerned about this pest. Next slide. So this is a life cycle of the pest. We're going to make a little video as well in a minute or two about the life cycle, just to see the diagram. So there's really four main stages. You've got the female. They're all females, not males. So the females do not need to be fertilized. They basically can lay eggs without having there's no males in the system. So it only takes one female to get on the nursery. A population starts. That's one of the reasons why the pest is so successful. The eggs, you can see here from the information on the right hand side, the adult emerges in the spring, and basically she'll lay a lot of eggs, but it depends on the temperature. So at 11 degrees C, it takes her 5 months to lay her first egg, and she can lay about 70 eggs, and it's just under 1 millimeter in size each egg. But if you get up to 15 to 27 degrees, within that range, they start laying eggs 30 to 50 days after hatching, and they can lay between 400 and 1,100 eggs per female. They overwinter by hiding away. There have been cases where vine weevil can survive up to 3 years. But generally speaking, it's more like a year and a half. They mainly hide. They'd say that the adults will try to survive, but most survival is through the larvae in the compost. And the larvae, they're through a series of molting. So they start as a small larva, and then they get larger and larger until they get to the size where then they become a pupa, and then they hatch again in the spring. So we're going to try a video. The audio doesn't work, unfortunately, so I'm going to try and talk. I'm going to try and talk a little bit as the video goes for you to understand the video, looking at the life cycle of the vine weevil. All of these videos are available with the audio on Koppert YouTube channel, so you can go back and have a look yourself on YouTube if you want to see the audio version later on. So here you can see the female weevil. Okay. Looking around, feeding on the leaves. When she gets enough food into her, she will then lay her first eggs. Everything, this all happens at night time. It's totally nocturnal activity. And here's the larva. They can be hard to find sometimes. They can hide in the root ball of the plant. You see this shape of notch and you know you've got fine weevil. As I said, it's in the video, it's saying here are the eggs. This is what the eggs look like. So they're white to start with. You can see the first egg's white, then they turn brown as they mature, and then you can see the little larva inside there, inside the egg, developing. And then hatching. So saying here, it first feeds on organic matter before it moves on to roots. And it starts off with root hairs when it's a very small larva, but as it becomes a larger larva, then it wants to feed on larger roots and eventually into the core of the plant. I think maybe the video is possibly being a little bit slower because of the subtitles. Maybe Connor knock off subtitles for the next video, because I think it's slowing it down actually. That's it, that's much better. So it's developing obviously, and then it eventually becomes pupa when it becomes large enough. This is the pupa. You can see the legs all folded up. It looks the shape of an adult now, but it's just white in color. It's no prizes for appearances. So it makes sense. Typically an adult can live about 12 months. 3 years is not unknown. I think that's enough. I'll stop the video there. So we went through the life cycle. Next slide. Here's what the eggs look like when they mature, as we've seen in the video. Next slide. This is giving you a little bit of information about how long they take to live. So if you look at the very bottom of the table, you see the total length of time that it takes them to go through their life cycle. So at 11 degrees, it's taking 260. Okay, 11 and 12 it's around about 300 days, 270 to 300 days, 11 to 12 degrees. But as you get warmer, the life cycle speeds up, and you can see the total from egg, the pupa to adult, to then is really short. So from egg to adult, basically you see here, it shortens a lot. So it's a long time from egg to adult at 11 to 12, but when you're getting in the 18 degrees plus, you can see it's quite fast, 156 days from egg to adult, and then obviously the adult can live up a year after that. Then once it's become an adult, you understand what I'm saying. So it goes somewhere between 300 and 123 days, depending on whether it's 11 degrees C or 24 degrees C, the ambient temperature. And everything's about temperature with these. It's not daylight. Temperature is the most important thing for development of vine weevil. Next slide. So we're just going to have a little look here. This information comes from an AHDB table. You'll find it on their website if you have a look, and it shows you the range of plants that are affected by vine weevil. So the first table is showing you, first of all, conifers, and it mentions 5 conifer species at the top of the table there, including junipers and taxus and so on. And then below that, you see the list in red of the susceptible shrub species, including azalea. You can see heathers there, cotoneaster, for instance, fuchsias, a whole range of plants and pieris and so on. And then on the right hand side, the green ones, which can occasionally be fed upon, but are not fed upon so readily as the ones in red. And so that's the shrubs and the trees and the conifers. Next slide will show you the list of herbaceous perennials. We'll have a look at that. So you can see the list in red of herbaceous perennials that are tacked on most, and then in green ones which wouldn't be attacked on so often by the larvae of the vine weevil. Again, a big range of, I'm sure that's not exhaustive either, that's just some of the plants that the ASDB put together as the main ones they wanted to highlight to the growers in the UK. So this highlights the problem, being such a wide range of host species that the pests can attack. Next slide, please. And the big problem today, why we're actually having this event, really is because we're now in a situation where there is a big challenge to growers, and the fact that there's no compost and incorporated pesticides that can be used for 2021. Next slide. So we have to look at what we call an integrated pest management. That's what IPM stands for, integrated pest management strategy, to control these vine weevils, since we can't rely on a chemical incorporated control. So on our next slide, we're just going to go through these steps. So IPM is really something we all need to get our head around. And in this case, there's five things could be looked at, and we're going to look at each one of them in more detail in the subsequent slides. So you've got 1 to 5, monitoring of both adults and larvae, for cultural control, including good practice in the nursery, out control. I've got chemical control in there, but you'll see yourself that it's not really going to work for this particular thing now because of the lack of chemicals. The next slide. So for adults, what we need to be doing is thinking from April onwards, when they've hatched, or even sometimes in a heated situation before that time, we're actually going to be looking for adults. Well, they're nocturnal, so you can actually discover them by walking around with a torch at night and finding them. If that's not practical, then we need to look at alternatives. We could have indicator plants, and 3 species which are particularly good for this are Euonymus, Primula, and Yew. So we could look at having those within the crop area as indicator plants. So we're looking for the C-shaped notching, or maybe then tipping the plants out and looking for the larvae as well later on. But we'll get a very good idea that adults are feeding on those, because they'll see the C-shaped notches very quickly on the indicator plants. We're also going to be looking at using what we call refuges. So you might look under containers, under container rims, in plant debris. You might have purpose-built refuges. So you might use grooved boards or corrugated plastic. You might put 2 pots together and tape them up with straw inside, and then dismantle them and have a look at any weevils get inside the pots inside the straw. And there are even now, we're getting close to having commercial traps. So the ASDB are doing work, and if you look into this yourselves, you'll see that they are looking at finding traps that could be commercially available to help monitor for this pest. Next slide. Also, you need to really think about when you bring in plants, that you're checking those plants. So you should take a sample of all the plants that are in susceptible species and check them for presence of larvae by tipping them out, and even taking apart 1 or 2 roots to have a look inside the core of the plant if necessary. Also, your plants that are in stock on the nursery, if they're susceptible species, if you see any sign of stress or wilting, you should be looking again in the root balls for signs of larvae. Okay, so it's continually checking susceptible species on a routine basis, and checking all plants that come in on the nursery as well. Having this policy on your nursery of making sure everything's checked. Next slide, please, Connor. Cultural control. You should be asking your plant supplier, what are they doing? What is their policy against vine weevil? They should be able to provide that to you, so that you are feeling assured that they're doing everything possible to control vine weevil. For instance, we have suppliers in the south, propagators in the south, who use our nematodes. all of their plants now, and they can inform their customers of how they do it and when they do it, and every batch of plants has been covered with the nematode treatment. That's for example. But you need to ask your supplier what they're doing about that. Don't accept any bluff. You need to know. If you have unmarketable plants, make sure you get rid of them. Don't have them sitting there. Don't keep walking past them. If you know there's damage of fine weevil and the larvae are in there, you're better to get rid of those plants in sealed containers and dispose of them off-site. Again, compost has been riddled. Get it off-site. Don't keep it on the nursery. Weeds can be a major pest refuge. 3 particular weeds that are listed by the ASDB are dandelions, docken leaves, and rose bay willow herb. So if you have those on the nursery, you need to get them off the nursery. You need to make sure they're wet out because they are going to be a source of a problem. Again, ASDB report talks about different composts, and one that particularly stands out is core. Core seems to be particularly favourable to vine weevil development as opposed to other compost mixes. We know that, of course, they will also lay their eggs in other compost mixes, but core seems to exacerbate the numbers. Next slide, please. So moving on to where we're going to get into a bit more detail is the viral control. So you've got 3 options here. You've got your 2 different nematode species depending on the temperature that you're going to apply them at, and we'll talk about that as we go through. And then there's Net 52, which is another product, which isn't our product, which you can look at yourself into. It's a soil incorporated granular product, but there is a big problem with that, the fact that it doesn't actually work really until about 15 degrees C, where some of the nematodes work between 5 and 8 degrees C upwards. So they're more viable in terms of a bigger range of temperatures than the Net 52. Next slide, please. Chemicals. Well, chemicals used to be part of the program, but the problem is there's no soil incorporated insecticides available for 2021 with the loss of Exemplar and Calypso disappearing on the 3rd of February this year. So it cannot be used either. And again, products which were talked about, so that's for basically some growers will be applying sprays just in the early evening at night to try and kill off the adult vine weevil. Well, again, they're not even available. If you look there, basically chess would have been the thing that would have been recommended. It's gone. Calypso's disappearing now as well. So there's really no IPM compatible spray that you can spray the leaves with either to kill the adults as they feed. And so that part of the strategy has disappeared too. There are still some chemicals that could be used, but they're beyond IPM incompatible. And again, that's up to yourselves to investigate that. There's nothing I can recommend from an IPM program point of view. Next slide. So let's look at the nematodes and how they work. Next slide, please, Connor. So basically, this is a little bit of a history of nematodes. They've been around for millions of years. They've been discovered in the 19th century. And since 1986, Koppert have been manufacturing them. If you can see the picture in the circle there, we'll get a better picture later on, but it's like industrial scale vats, almost like a distillery. You could describe it as when you look at it, where we mass produce nematodes. And we've made a lot of gains this last 2 years with new formulations, new gel formulations to make them much more dissolvable and much easier to use, longer shelf life and so on. So since 2017, we've increased the shelf life, we've made them more dissolvable and more user friendly. Next slide. A little bit about what nematodes are. Well, the nematodes that we use are part of a huge family of nematodes, but we're actually looking at entomopathogenic nematodes. Entomo standing for insect, pathogenic standing for disease causing. So they cause they basically kill other insects. That's what they do. And they're soft-bodied, non-segmented roundworms. They're about 1 millimeter in length, depending on the species. Some are slightly less than 1 millimeter, some are more. They're all soil-borne. They're all naturally occurring. And there's 2 species we're going to be having a little look at. Move on, next slide, please. So the first one is Steinella feltii. This is a cold tolerant species called Entonem. Next one, next slide, please. And the second one is Larvanem. This is Heteropodus bacteriophora. It's a warm tolerant nematode species. And basically, for year-round control, we have to use a combination of the two. Yeah, if we could show the video, but don't do the subtitles because I think it slows it down. So actually, this video, although it's showing a caterpillar, gives a really good way of how nematodes work. The reason why we're showing caterpillar here is because we're now very confident that we can control caterpillars using nematodes. So this is why this video has that as an example. You see the nematodes here; they've entered through the breathing parts of the cuticle of the insect and got inside the insect, and now they're floating around. This is what you call the third stage, the non-feeding stage, and that's the stage that lives outside the insect's body, and it's now inside the body. And what they're doing here, if you see this little white thing at the head of the nematode, that's where it's going to release its bacteria from. Each of these nematodes have got bacteria that live inside them. They're what you call symbiotic relationship. They have to have each other. They can't live without each other. So now it's releasing at the back end here all the bacteria into the gut of the caterpillar. And these are the bacteria in large. You can see the bacteria floating around now. These bacteria basically help the nematode to digest the contents of the insect, and that's how. And then the nematode can suck up the contents that the bacteria have broken down for them. But the bacteria basically cause the insect to die because they actually give it almost like septicemia, and that is how you would describe it. They would go like a brown mushy color or a red mushy color depending on the nematode species and die. I just thought you might be interested to see. So this is the content. This is the contents that the bacteria broken down here, and this is how then they're absorbed by the nematodes. The nematodes absorbing the food, the digested contents that the bacteria broken down inside the gut. And then you can see here, then they become the fourth stage, and then they become adults and they mate. And then they lay eggs, and new eggs become new nematodes, which then re-emerge from the insect. All right, okay. So this is the diagram explaining what you've just seen in the video. So you can see here on the top, that's the grub, and you can see below the grub there's a little nematode. That's the free living one that's in the soil. That's the immature juvenile stage, the stage 3 that you buy in a pack of nematodes. They're all that stage. That little third stage enters through breathing sphericals, the mouth parts and the anus of the insect. There's also one of the species we sell also has a little hook, so it can actually push its way in through the cuticle of the insect and get in that way. And once it's inside, then it goes through all the different stages. Before it becomes an adult, and then it actually lays its eggs, which then become stage 1, 2, 3, and then they can be released back out of the nematode again. But that's really what's going on. Most of the life cycle takes place inside the grub, and only one part of the life cycle is outside the grub. And the whole process there, you can see, they release the bacteria, they kill the host is about 48 hours typically. So once that gets in and they've released the bacteria, it takes 48 hours to kill the insect. Next slide. So it's quite fast, the process. And immediately they're going to be almost immediately looking for, as they settle in, they're going to be immediately looking for a host. How they find the host is basically the two ploys. They either ambush it, so they sit and wait for the host to come past them to conserve energy, or they cruise and they look for the insect by following a trail. They can hone in the insect. They can actually pick up a trail and move towards the insect and get in that way. Next slide, Connor. This is what typically what a vine weevil larva will look like when it's dead. So you can see it's become mushy. So the septicemia has taken place, and then this has become a mushy brown color. Sometimes it's red, sometimes it's brown, sometimes it's yellow, depending on the insect, depending on the nematode species. So the larvanem will turn it red, whereas the entonem will turn it yellow. But it's mushy. Okay, it's dead. Next slide. So this is just examples of other things that nematodes attack. Each of our nematode species attack more than one thing. So you'll find that the whole range, you can see the top left here is a type of beetless. You can see the nematodes wriggling inside it. You can even see like a pupa here in the bottom left with the nematodes inside it, and a larva on the bottom right with nematodes wriggling inside it, ready to burst out. Next slide. So we're going to now look at some information about what temperatures you need to use and when you use each nematode species because of the temperatures required. Next slide, Connor. Okay, so there's a lot of information here, so I'll explain to you what you're seeing. What we did, what we actually did, this is done in an oven to get all the information gathered on different temperature ranges. So we set up temperatures between 10 and 40, and kept the temperatures constant. And you can see here then on the right hand side, we're able to plot out what the best temperatures are to kill what you see here on the mortality of grubs. So we then introduced grubs, and we can see the percentage kill. So you can see here, if you look at the blue, that's the Entonem. That's the second graph down. Forget about the first graph. This is control, but the second graph down, you'll see the blue graph. That's the Entonem. So you can see there, it's sitting at 15 degrees C. You've got 100% kill, but you've probably got about 75% kill below that temperature. And you can see here then the temperature, it stays a very good kill up until about 25, and then it drops off. So it doesn't like warm conditions, the Entonem. It's a cool, loving nematode. Ignore the middle one because it's not relevant to vine weevil, but the third graph down there then is the Larvanem. That's the green graph. And you can see the Larvanem has a different type of graph. You can see that it doesn't like the cool conditions, but it does very well towards the warm conditions. So in the summer months, it's going to do very well, even into the plus 30 degrees, it'll still work before it decides it's not going to be working any longer. So you can see it's very high tolerance, right up to 32.5 degrees C, where you're still getting 75% kill. So between 19 and 32.5 degrees C, you're getting above 75% kill. With the Entonem between 14 and 26, you're getting a 75% kill or more. All right, so that's what that's showing. Next slide. This is just that's another way of showing information, that top graph. So it's showing there, again, the blue is the temperature that the Entonem likes to be at a cooler temperature, whereas the green one, it likes to be at the Larvanem likes to be at a warmer temperature. But there's another way of looking at this. We also looked at giving fluctuating temperatures, which is a more realistic thing. So if you look at the next bar graph, what we're showing here is if we expose over a 24-hour period, if we expose the nematodes to 4 hours at 4 degrees C and 20 hours at 21 degrees C, this is the result. So when you're giving 4 hours at 4 degrees C plus 20 hours at 21, you're getting 100% kill with the Entonem. Larvanem doesn't even show at that stage. You can see that. Forget about the middle graph. It's caps in them. It's not relevant. The middle one then, you can see the blue and the green. They both get a reasonably good result at 21 degrees C. That's a very good temperature range for nematodes generally. But then if you get into the high range, you can see the Entonem doesn't work so well any longer, but the Larvanem still works very well. So you can see here, if you've got 4 hours at 35 degrees C plus 20 hours at 21, Larvanem still works. So we're trying to show you, that you've got two extremes here, where you can have a fluctuating temperature of very low, very high, and you've got a nematode that does the job. Next slide. Hence, knowing this information, you can look at how you can actually use a combination of the two nematode species with different temperatures. Now, this is old information. It's 2004, this information. We've done a lot more information since then, but just to show you, for example, if you just do one treatment, this is not repeated, but just one treatment there at one, you can see here different temperatures, what happens to the two species for that 2004 data. So you can see, obviously, the Larvanem likes to be in the higher temperature. You've got a 12 degrees C where it's a sort of switchover point between the two. And we'll talk a little bit. Show the next slide, please, Connor. So what we're recommending is, because of this, we're saying if you have plus 14 degrees C, you should use Larvanem, but if you have 13 degrees C or lower, you should use Entonem. So anywhere between 5 or 8, between 5, 8 degrees up to 13 is definitely Entonem territory. Above 14, you're getting into Larvanem territory. So hence, throughout the year, you will switch nematode species depending on the time of year because of the temperature of the compost. So it's all about the compost temperature and which nematode you should be using. Ideally, we should be looking at timing our nematodes for when we have got a target. So we're looking at larvae being in the compost. So if you have overwintered nematodes, that means you're going to have to treat them in the spring. So you're going to be thinking about using Entonem through March and April time. And then you're going to think about it maybe, it used to be the old advice was to apply 2 applications of Larvanem in August, September. But more up-to-date advice would tell you that the best strategy would be to apply Larvanem once a month at a half dose rate. So a half dose rate every month through the months probably of, through May, June, July, August, September, October is the optimum strategy for controlling vine weevil. Next slide. Next slide, please. So here's the vats that we manufacture them in. This is showing our team who run these facilities. We've been investing very heavily in the last 2 years and more because of the scale that we require, because of the new ways we're using nematodes. We need to have more of them because we're doing them for caterpillar control and so on. Next slide. So here's some key facts about Entonem, and then we'll show you key facts about Larvanem. So if you buy a pack of Entonem, it's going to have the species Steinema feltii in it. These are naturally occurring around the world, and the typical size is somewhere between 0.7 and 0.95 of millimeter, the size of each nematode. They can be used for foliar and soil. For our purposes tonight, it's for soil application only, because we're targeting the larvae in the compost. This particular species can take cold shocks, as we talked about, at 4 degrees C for 4 hours in a 24-hour period, no problem. It can handle that very well. Its optimum temperature is somewhere between 14 and 26, but it will survive between 5 and 35, generally speaking. It will have some survival, even although you are getting a bit of death at the top end of the 30, below about 32 for the Entonem. Next slide. Some key facts about Larvanem. Again, we're looking at a species called Heterobatus bacteriophora, found around the world. A slightly larger nematode, somewhere between 1 and 1.5 millimeters in length. Again, can be both foliar and soil, but again, for our purposes, it's soil only for vine weevil control. It takes hot shock, so we saw 35 degrees C, 4 hours in a 24-hour period. Doesn't do the nematode any harm at all. So it will take quite high temperatures. But the optimum temperature is somewhere between 19 and 20 and 33 degrees C for this particular nematode species. Next slide. We have 3 pack sizes that you would get them in, depending on your scale. So you've got a very small pack size, which has got 50 million nematodes on the right-hand side here. Then on the left-hand side, we have what we would call our 500 million nematode pack, which will be the one that most reasonable scale nurseries will be using. Then in the middle, we have a new one for this year, which is a 2.5 billion pack of nematodes for large-scale production. Next slide. Keep going. Keep clicking there, yeah. There's a few more points to come on that slide. 5 points, yes, it. So let's just go back there. That's it. So basically, what we're saying here, we've got a new gel formulation. Now, there was a video I'd love to show you, but unfortunately, it won't link up today. But we'll maybe see it in the how-to video a little bit. How well the nematodes dissolve now. Everything's biodegradable. It dissolves very well. It doesn't have any residue on the leaves, and it's got a long shelf life. In the case of Entonem, 14 to 16 weeks in the fridge. It can be kept. Larvanem doesn't keep quite as long as that, but it has a reasonable shelf life, maybe 6 weeks plus for Larvanem. Next slide. Keep going. Keep going. Yeah, I think we've actually repeated that slide somehow or other. Yeah, how do you apply? So, next slide. So, here are 10 points to know if you want to have 10 golden rules, okay? So, temperature is everything. One thing I saw, a common mistake, somebody had bought the nematodes and put them in the fridge, but they hadn't taken them out of the polystyrene box. So you must remove them out of the polystyrene box when you receive them, otherwise they heat up and die. So they must be kept between 2 and 6 degrees C upon receipt immediately, otherwise they will heat up and die. That's very important. You need to make sure that you dilute them properly. We're going to show a little video, a how-to video, and you'll see how they're prepared soon. But so make sure they're dissolved, and make sure you continue to stir them. Make sure you avoid the middle of the day. You don't do it in bright sunlight. It's really important. They're UV sensitive. They're also temperature sensitive. We talked about the temperature range already. They're humidity sensitive in the point of view that they do like to have a reasonably moist compost. So you want to think about pre-irrigation before you spray, and keeping the compost reasonably moist after application for, if you can, up to 2 weeks. It's better. You don't let the compost completely dry out. So it talks a little bit about what you should avoid here in terms of spray systems, avoiding centrifugal pumps and pistons. Okay, you want to have a maximum of 20 bar, which is actually quite a high pressure, so they're quite tolerant of pressure. Filters should be removed, particularly if they're below, if they're 3.3 of a millimeter or below in mesh, they should be removed. So think about, if you're going to apply these through any particular systems, think about where all the filters are. Dosatrons have filters. Remove the filter from the dosatron, for instance. If you're going to tank mix them, then that's usually quite okay. The nematodes are actually very tough little creatures, and they will tolerate quite a few pesticides. So don't be, you don't think that you can't do that. The thing it is, what you need to do is check the side effects app that Koppert have to tell you which chemicals are safe and which are not before you do it. If you do use chemicals, make sure you have them diluted in the tank before you apply. Don't have the nematodes in the diluted tank, not the other way around. Don't put them against neat product and use them rapidly. Okay, they shouldn't be sitting in the tank. Once you've made it up, get them out. Okay, next slide. So here's our side effects app. It's free of charge. You can download that on your phone, either on the Android or the Apple. You'll find this. It's called the Koppert side effects app. It's free of charge for anybody to use. And it just allows you to enter the chemicals, either by the chemical name or active ingredient, and then the biological that you want to check against. In this case, you'll type in Larvanem or Entonem, and you'll get a result table showing you how dangerous or how safe it is to use. Green, number 1, means it's safe. Then you have number 2, which is orange, which is yellow, which is reasonably safe. Then you have amber, which is 3, which is not so safe. And then you have 4, red, which is definitely incompatible. And then it tells you how long it's incompatible for, a period of days to weeks. It'll say in the bottom anywhere between 1 day and 16 weeks in some instances, depending on the chemical, how long it can be dangerous for. So have a look at that side effects app for yourself. Next slide. Okay. So that's a quick run through. I'm sure there's a lot of things still to cover and some questions. Very difficult to cover everything in detail. There is a video if you want us to show. That's my contact details. But there's one more video, Connor, just to show on the how-to video. You can see here it's telling you preferably if you could leave it out to acclimatize, it's better. And it's also talking about the temperature. So you can see here 15 degrees temperature of water is perfect. You're just emptying them in. You can see how quickly they dissolve in here with the new formulation. Very easy, just a quick stir around and they dissolve very fast. The old formulations were much harder to dissolve than this, so We really cracked it this year. We've got a far better formulation. Preferably 5 minutes resting if you've got the time. Some people don't. they just put it in the tank, but ideally a couple of minutes or more resting would be useful. And obviously you have your tank filled with water before you add them, then agitate the water in the tank. So this is some foliar application can happen. It is possible to use overhead irrigation for nursery stock, and it will work as long as you have got access to compost in the pots. So that overhead irrigation is something that can be used. It depends on the situation. Sometimes doesn't work if you have large pots or if the canopy is closed over, and that means you may have to apply directly to the compost using a sprayer. Again, all of these videos are on YouTube. You can look them up yourself afterwards.
So we'll go back to Connor now. So if there's any questions come in on the Q&A, Connor.
There's just one or two here, yeah. Like the first one is where can these be sourced, or how does a grower get access to the Koppert products, who's the supplier here in Northern Ireland?
I think what we need to do in the first instance, chat to myself. We'll sort out how that works for people. They'll come to me first, and we'll have a discussion about how to source the products. So that's the best thing to do, really, just to talk through the technical issues first of all. If someone's interested, then we'll introduce them to the Koppert suppliers for nematodes. We tend to work through agents, so that's how we work. Okay, so Koppert have a supplier in Ireland called Unichem, who do a lot of stuff for ourselves. But they talk to themselves first of all, and then we'll put in touch with the contact point.
Perfect, thank you. Is there any issues with the irrigation systems if you're putting it through the dosatron?
No issue with dosatron. Dosatron is totally compatible with the dosatron system. In fact, again, if someone's interested, I have a little guide that I can give them. Koppert have produced for using nematodes in dosatrons, and we can supply that to them by email, and they can read that, and we can have a chat about the thing, and it's not a problem at all using dosatrons. So Perfect. It's just about obviously getting the concentration. It's like setting up the right concentration of dosatron to apply the product. But I say we have a guide for that we can show people if they're interested.
That's perfect, thank you. And is there any impact on beneficial insects by using nematodes?
There are some impacts with certain species of nematodes. So if you're doing foliar application, there are some beneficial insects that they could actually have an effect on. The Entonem doesn't tend to have too much effect. There's another nematode called Capsinem, which can have an effect. We're not talking about Capsinem today anyway. But again, we have the side effects, and we know which we can give advice on that. Again, depends what people are trying to do. So if they're trying to use another beneficial insect to control another pest, we could give them advice on that, depending on what they're trying to achieve. But when you're doing compost incorporation, there's not an awful lot that's going to affect, really. A theta, maybe. The theta bug could be something that might be affected with people using those. I don't think that's going to be a big issue for most people.
Perfect, thank you. Another question just came in there is where it hasn't worked previously for growers, where they maybe have used IPM or a system like this before, where do you think they've maybe fallen foul to it before, and will it work better for them now?
That's a big question. We need to know the specific details. I mean, there are many reasons why it may not work. Obviously, some of the obvious ones we've talked about, and temperature is critical. Incorrect storage, incorrect application methods. There's many things that could go wrong. We would need to delve into the situation and understand how it was applied to actually try and work out why it didn't work. But it's commonly used now. We have quite a few growers who in the nursery stock trade in the south of Ireland. There's a number of them here in County Koppert, for instance, who are regularly using nematodes for with ourselves now. All the strawberry growers throughout Ireland, it's 100% nematodes. There's no chemicals whatsoever, and they're applying them through their dripper system, actually into the bags, and they always work as long as they're applied following all the rules, of course. If something's not done correctly, there's a chance it won't work. Some of the growers like to use food colorants in the water so they can be sure that the nematodes have got to the end of the line. That's very important. So we have to make sure they get to the end of the line. Think about the time to get to the end of the line. We also need to think about flushing them out of the line. Don't leave them in there. So there's things like that that could go wrong. So it's attention to detail, knowing when they've got to the end of the line, knowing when we flushed them out of the line, and doing some tests with coloured water to help you work that out.
That's great. And I suppose just on that point, is there much of a skill set involved changing over to an IPM system for a grower, or is it fairly straightforward?
I think the main thing is more attention to detail and the fact that you know it's you haven't got this incorporated compost in there to save you. So therefore you're going to have to really think about the 5 steps, or the 5 steps. And the monitoring is going to be so much more important than before. And the checking of young plants and the removal of old plants and the removal of weeds. Understanding the life cycle and what you're dealing with better than taking time to understand the life cycle of what you're dealing with. I think all of those skill sets, but the actual use of nematodes, it's not a highly skilled procedure. Once you understand how to do it, it's quite a simple procedure. From that point of view, I think people can pick it up quite quickly. Just all the other things around it and implement the IPM program to ensure you're doing everything to keep the nematodes, to make sure the lining was kept in low numbers. Is the thing that people are going to spend more time on. And thinking about trapping and monitoring hygiene.
That's great. I suppose just on that as well, is there much advancement in regards to the use of IPM in outdoor production? I know most of this will be for protected crops. Is there much going on in regards to outdoor?
The last 3 years, there's been a big momentum towards outdoors, and Koppert have set up an agricultural division. So we have a totally separate division now called the Koppert Agri, which wasn't there before. So we have Koppert Agri, Koppert Horti, and we also have livestock as well. So there's 3 divisions now within Koppert. So outdoor is where we're making the most grounds in outdoor are things like carrot fly control with nematodes. Maybe thrip control with mites in onions, for instance, things like that. So you're going to see more and more outdoor use where we've got an applicator now which goes on the back of a tractor, which you can apply a whole range of insects now to. It's just so 2 men can do hectares on a day. And we have 2 of these applicators already in place in the south of Ireland in strawberry growers. So they've got these tractor mounted applicators. So they've got 2-man operation. Put out the biologicals out the back of the tractor. So this is starting to happen very fast now. It's the 2nd year where we've been using the applicators for the strawberry growers, and say the outdoor use is expanding more and more all the time. But we're still early days. We're having a lot of discussions with ASDB, for instance, about how we can look at more and more outdoor IPM systems because people are running out of options. But it's still at the early stages. Where IPM is the most advanced is in salad crops. So in tomatoes, peppers, cucumbers, it's nearly 100%. Strawberries is getting more and more close. It's becoming much more towards IPM than it ever was. That's because of residue testing. I think there's at least 3 different bodies do residue testing for strawberry growers now. So therefore, they can't afford to have anything out of line. And so we're making big inroads into soft fruit. I think ornamentals is the area that's still lagging behind. And that's something that we hope to address over the next few years. I think spider mite control might be the next thing that would be looked upon because it's very easy to do spider mite control using biologicals. And if that could be something that maybe could be looked upon for ornamentals as the next step, in my opinion.
Yep, that's excellent. That's all the questions that have come in.
Okay.
Kieran?
Yeah, I've just a couple of questions, David, quickly.
Yeah.
I appreciate it. In the past, is there any advantage in mixing the nematodes in lukewarm water? You said 15 degrees in the video. is 15 degrees the ideal? In the past, some of them would have mixed them in slightly warmer water.
15 to 20, don't go above 20.
Right, okay.
Definitely don't go above 20 degrees.
Right, and then the last question I have for you, David, is, and you would appreciate this, from, as you would know, nurseries, some of them are immaculately clean, to some of them with having vine weevil on the nursery, unfortunately. How effective are the nematodes where vine weevil is already established?
Well, again, I think there's a point where plants have to be disposed of. So we'd have to, but they are curative. They need to have larvae in place to work. What I should have said and I didn't mention was how long they would last for. So typically, you will get about a 4-week lifespan out of a nematode in the absence of a prey. So therefore, every 4 weeks, you should reapply. So you want to have the larvae in the compost, Kieran, for these to work. But again, there's a point when it's too much. And it's really knowing that balance, isn't it, between too much and the right amount.
Right. Thank you, David. So there's no more questions, Connor?
That is everything, yeah,
Right.
on my side.
Okay, so I would just like to draw the webinar to a close. I'd like to thank you all for joining in. I would sincerely like to thank David Davidson for his excellent presentation on the nematodes for the control of vine weevil. I'd like to thank Connor for facilitating the webinar tonight. We are more than keen to become actively and proactively engaged with the ornamental sector, and that will be Connor's remit going forward. I am very keen that this is our path of travel for in the short term, and I would like to organise a webinar in the near future, ASAP, on it's on importation of plants, moving plants from GB to Northern Ireland. So, when the busy time comes, when it does come upon us, that you're in a position that the flow will be seamless. So I would like to organise a webinar in the near future, and we should be fit to capture the contact details of the people that joined in the webinar tonight, and we will be sending details out of the webinar on moving regulated plants and plant products from GB to Northern Ireland. But just to make sure to get the ball rolling, and in advance of that, you want to make sure that your business is registered with Plant Health with the Department of Agriculture in Northern Ireland. So you want to be registered. You can do a Google search. If you're not already registered under the professional operator with Dara Plant Health, you need to be registered on Traces NI to get it's called an XI EORI number to complete customs import declarations. But the two things, make sure you're registered for Plant Health, which most professional businesses are, and to be registered on Traces NT. So we thank David again for speaking. We look forward to future suggestions for webinars, and don't be afraid to contact Connor or myself with any further queries. So with that, I will draw the webinar to a close, and thank you. Bye-bye now.